Hi everyone, today we are going to study subgraphs in graph theory. So if there is a graph small g which is said to be a subgraph of capital G, that means we have two graphs. One graph is denoted by small g and the other graph is denoted by capital G. So in that case, if all the vertices and edges of the graph denoted by small g are in the graph denoted by capital G, and each edge of small g, that means each edge of the graph denoted by small g, has the same end vertices in small g as in capital G, then graph denoted by small g is said to be a graph is said to be a subgraph of the graph denoted by capital G. So if all the end vertices of small g are in capital G, all the edges in small g have the same end vertices as they have in small capital G, then in that case small g is called a subgraph of capital G. We will consider this example through an example of a diagram. So if I look at these two figures, you look at the figure A representing one graph and figure B representing another graph. So I can say that the graph in figure B is a subgraph of the graph in figure A. How? Now please take a close look over here. Look carefully. Now you can see 6 vertices in the graph A. 1, 2, 3, 4, 5, 6. There are 6 vertices. Though out of those 6 vertices, there are 4 vertices here in figure B. 1, 2, 3, 4. So this portion of the graph in figure A is shown here in the graph in figure B. This is the portion of figure 1 that is shown here in this is the portion of figure A that is shown here in figure B. Now we will see if this graph in figure B is a subgraph in figure A or not. How? The first condition is that all the end vertices of this particular graph should be in this graph. So the end vertex 1, 2, 3, 4 in the graph in figure B are all present in the graph in figure A. 1, 2, 3, 4. Then the other condition is that all the edges in the graph B should have the same end vertices as the edges in graph A. So if I look at edge A in graph B, it has the end vertices 1 and 4. Similarly, edge A in graph A has the end vertices 1 and 4. Then the edge C in graph B has the end vertices 2 and 4. So does the edge in graph A has the end vertices 2 and 4. Then the edge E in graph B has the end vertices 3 and 4. So does the edge in graph A has the end vertices 3 and 4. Now the edge in graph B, the edge B in graph B has the end vertices 1 and 2. So does the edge B in the graph of figure A has end vertices 1 and 2. Then the edge D in graph of figure B has the end vertices 2 and 3. So does the edge D in graph of figure A has end vertices 2 and 3. So we can clearly see that all the edges in both the graphs have the same end vertices. First of all the edges of the graph in figure B, all the vertices of the graph in figure B are present in the graph in figure A. Then all the edges of the graph in figure B has the same end vertices as in B in the graph in figure A also. So I can clearly say that the graph in figure B, this graph in figure B is a subgraph of the graph in figure A. Obviously, one thing that should be noted is that when we are considering a subgraph, the original graph must not be altered. And in any ways, the original graph has not been altered here. If you look at it carefully, it will look like as if you just cut a piece of this graph and put it over here. You just cut it and put it here. Nothing has been altered. So whenever you consider a subgraph, you must consider the fact that the original graph does not get altered. So such a graph in figure B is now can be called as the subgraph of the graph in figure A. So this is the concept of a subgraph. So basically a subgraph can be thought of as being contained in another graph, right? You can think of a subgraph as a graph which is contained in another graph, because if you look at this graph in figure B and then if you look at this graph in figure A, you can clearly see that this particular graph seems to be contained in this particular graph. So we can say that a subgraph can be thought of as being contained in another graph. So if small g is a subgraph of capital G, then the symbol of G is a subset of small g is a subset of capital G is used in stating that small g is a subgraph of capital G. So the same symbol which is used in this set theory, here also it is used, that is if small g is a subgraph of capital G. So how will you denote it mathematically? You will denote it through this symbol which shows that small g is a subgraph of capital G. Now regarding a subgraph or a graph, regarding a graph, the following observations can be made. First observation is that every graph has its own subgraph. Any graph you take will have its own subgraph. If small g is a subgraph of capital G, then a subgraph of G, small g, is a subgraph of capital G. So that means if small g is a subgraph of capital G, then if there is any subgraph of this small g, then obviously that subgraph will also be a subgraph of this capital G, because G is contained in small g is contained in capital G. So if a graph is contained in small g, then it is quite obvious that that graph will be contained in capital G. So if G is a subgraph of capital G, then a subgraph of small g is also a subgraph of capital G. That is quite obvious. Every single vertex of capital G, every single vertex of small g, every single vertex of capital G is a subgraph of capital G. Now, when we studied graph theory, when we were studying the introduction of graph theory, I told you that there can be a graph without edges, but there cannot be any graph with without vertices. A graph with even a single vertex is called a graph. That means one vertex alone is enough to make a graph. So in that case, we can clearly say that every single vertex of a graph is a subgraph of that graph, because a vertex alone can make a graph. So it is quite obvious that every single vertex of a graph denoted by G is a subgraph of that graph G. A single edge in the graph G together with its end vertices is also a subgraph of G. Also a single edge of a graph G together with its end vertices. Obviously an edge is formed only when there are two end vertices being connected. So when I say edge, the end vertices come by default. So a single edge in G is also a subgraph of G, obviously together with its end vertices. So if we look at this particular graph, the first condition says every graph has a subgraph. So if I consider this graph, it has a subgraph. This can be taken as a subgraph, or this particular region can be taken as a subgraph. So every graph has a subgraph. If I look at this particular subgraph, this can also have a subgraph. So if I consider this subgraph, which is a graph in itself, even it can have a subgraph. So every graph has a subgraph. This is a subgraph of this graph. This region is a subgraph of this graph. So every graph has a subgraph. Now the subgraph, if I call it small g and if I call it small j, the graph in figure B if I call it small g and the graph in figure A if I call it capital G, then as per the observation, if G has a subgraph, then the subgraph of G is a subgraph of capital G also. If this small g has a subgraph, then the subgraph of small g is also a subgraph of capital G. Now, if I consider this particular portion, this can be called this particular portion with vertices, end vertices 1, 2 and 4 and edges A, B and C. If this is a subgraph of small g, then it is quite obvious that it is a subgraph of this capital G also, because this particular subgraph is contained in this graph also. Then, as per the third observation, every single vertex of a graph is its subgraph. If I consider vertex 1, it is the subgraph of the graph G. If I consider this vertex 4, it is the subgraph of this graph small g. Then every edge with its end vertices is a subgraph of the graph G. So if I consider this particular edge I with end vertices 1 and 6, this will be considered a subgraph of graph G. So these are the observations related to a particular graph. Now let's look at edge disjoint subgraphs. Another category of subgraphs is known as the edge disjoint subgraphs. So two or more subgraphs, when there are two or more subgraphs in a graph G. So if there is a subgraph G1 and then there is a subgraph G2 of a graph G, then these subgraphs G1 and G2 of the graph capital G are said to be edge disjoint if the small g1 and small g2 do not have any edges in common. Quite simple, clear from the name itself. There is a graph capital G. It has two or more than two subgraphs. So here we are considering two subgraphs. So the graph capital G has two subgraphs G1 and G2. Now these subgraphs G1 and G2 do not have any edge in common. They do not have even a single edge in common. So in that case, these two subgraphs G1 and G2 of the graph capital G are said to be edge disjoint subgraphs. We'll look through an example. We'll understand this with an example. Now you consider these two graphs. Graph in figure A, graph in figure B, right? And then there is a graph in figure C. So the graphs in figure A and figure B are the subgraph of the graph in figure C. So I can say that the graph in figure 1 is G1, the graph in figure B is G2, and the graph in figure C is G, capital G. Right. So as per the definition, we have to prove that G1 and G2, which are subgraphs of capital G, do not have any edge in common. Now the edges of graph of the graph G1 are 1, 2, 3, 4. These are the four edges of graph G1. Now the edges of graph G2. The labeling we have done, the labeling is same, but the edges are not same, right? So these are 1, 2, 3, 4. These are the four edges of graph G2 and these are the four edges of graph G1. So now if we look at this graph, these two graphs are contained in its original graph G. So here you can see that this graph in figure A, which is denoted by G1, is this particular graph that I am talking of. It is this particular graph. The graph in figure A. The graph denoted by G1 is this particular graph, right? And then if I look at the graph denoted by figure G2, it is this particular graph. So as per the definition, you can clearly see that they do not have any edge in common. This is the graph denoted by G2 and this is the graph denoted by G1. So this is the graph of G1 and this is the graph of G2, and you can clearly see that there are no edges which are common in both the graphs. Hence, they are edge disjoint subgraphs. So any such subgraphs with two or more than two subgraphs of a graph G which do not have any edge in common are said to be edge disjoint subgraphs.